Since you have already written your roll number, your student IDs in the earlier session, you don't have to write it once again because the earlier chat has been saved. You just mute yourself, and I'm going to, first of all, I'm going to tell you how to use the Microsoft Excel to do the statistical calculation. Okay, so I'm going to share an Excel sheet with you, first of all. I hope that all of you can see this particular Excel sheet, which is in front of you. And this particular Excel sheet is a very practical problem. It's very practical sheet because it gives, as you can see, it actually gives my buying history during this lockdown 2020. Okay, during the lockdown, I have bought several books from Amazon. You see all the books names have been written over here, and serial number, how many books have I bought during this lockdown period. I have bought 22 books in total, and it is a fact. I'm not give you a vague data. It is a fact from my personal experience. I have bought all these books during this particular lockdown. Some books you can see has been colored. The names of the books have been colored in blue, and some books name have been colored in green. What is the difference between these two? Okay, so difference is in its category. The blue colored books are actually non-fiction books. They are kind of articles, or say, for you can very easily see their names, like quantum optics is there, stochastic process is there, mathematical statistics is there, plane trigonometry is there, and this is a biography, I am Malaila, so it is also a non-fiction book. Okay, then it is a book on gene, you know, actually the structure on which the entire human species is built upon, so it is also a kind of non-fiction. Then there is a book, a very good book, it is called How to Read a Book, so that is also a non-fiction book. So I have bought a few non-fiction books, as well as I have bought a few fiction books too. So like Journey to the Center of the Earth, then Ramayana, then Don Quixote, Adventures of Huckleberry Finn, all these books have been bought. Okay, so I have categorized them using two different colors. And the month in which I have bought these books, they have also been mentioned. So you can get an essence, this is called the data collection, you can get an essence of my buying, you can get an essence that how I actually bought things, how I bought these things. Okay, so and at what point of time. So you see the price list of these two items, are also mentioned over here. These are the prices, and you can see here in these two figures, I'm showing the cursor, the quantum optics books, and the book Dance of Photon. The price is too high, and if you think that whether I actually spend this amount of money to buy the books, yes, it is. Okay, because I'm a kind of crazy person and I'm very much addicted to books. So I actually spend this amount to buy the books. Okay, what do we want to study? I want to study, this price list is from Amazon. The data has been collected from the Amazon. So I want to study whether these prices of the non-fiction books and fiction books are connected to one another or not. So in the next slide, what I have categorized the two things. Okay, so I have shown here not the names, the data of the earlier sheet is just a data which is give you the entire view, like the name of the books, category, etc., etc. But I'm not interested about, right now I'm not interested about the names of the books. I'm only interested about their categories, and I'm very much interested about their price. So I have written the price of the fiction books over here and the price of the non-fiction books over here. So I have categorized the two things into two hubs, two columns. Okay, so how many samples are there at all in total? There are 13 samples. Okay, now If I want to study a, you can say that this price of fiction books, I can denote this by capital X, and price of non-fiction books I can denote by capital Y. Now suppose I want to study a correlation between the prices of the non-fiction books and prices of the fiction books. And I want to check whether when Amazon with its algorithm is placing the price, is there any sort of correlation between them? Okay, or if whether they are arbitrary. So I want to study the correlation between the two variables, for which I need to plot the scatter diagram first of all, to see the diagram of dots, how they are behaving. And secondly, I want to quantify, if the correlation exists, I want to quantify the correlation between the two. But when this particular experiment, this particular thought comes to my mind, immediately after getting into the experimentation, I need to clarify certain things. In the previous session, I already told you, that you cannot study the correlation if the number of items present in the column 1, that is for X variable, and the number of items present in column 2, that is Y variable, they are same. Until and unless they are same, you cannot study the correlation. But here you can see my the two columns, capital X and capital Y, they are actually not having the same amount of sample. Price of fiction books, the prices contain 9 samples, and the price of non-fiction books contain 13 samples. So I cannot find the correlation between the two. So I have to manipulate the data accordingly. I have to make the amount of, I have to keep the balance same. I have to keep the same amount of item on the X scale and same amount of item on the Y scale. So therefore, my sheet has been named as data manipulated. Now you can ask me that how you are going to select the data, because we are going to omit certain data from the chart and how we are going to include certain data into the chart. I have red marked something. You see these prices. This particular manipulation, try to understand the experimentation, because suppose you are doing in the actual field, how will you work? I'm trying to let you know that thing. Okay, so how you are going to do the things, prepare your chart as an experimenter. So what I have done, I have properly gone through the chart, and I have marked certain figures in red color. Say 5429, this price has been marked in red color. 7150, this has been marked as red color, and 995, this has been marked as red color. Okay, and 319 has been it's not in it has also been marked as red color. Why have I done so? Because these prices are in thousands, because too high these prices are. So I can, with respect to the other prices are containing actually in 100 scale, but these two prices are in 1000 scale. So I have decided to omit these two. Okay, there is also a kind of technical point for which I have done so, but I am going to tell you later on, not now. 95 has been omitted because it is a too low price. It is not actually, if I put 95 over here, then it is a 10-digit price. So I cannot, the parity will not be maintained. Okay, so I have omitted 95. Yet I see that one price is still greater. This is the one particular value is still to be omitted. We should omit one another price from the chart. And but then I thought, okay, this 319 I couldn't select. If I want to do so, I can do it by say, for example, I can select any of the 100-digit figures, and I can do it arbitrarily because I have no other option. Okay, so I could have omitted this 679, or I could have omitted this 715, but I have somehow there is no hard and fast rule for doing that, because I have no other option left out. So I have decided to omit this 319. You can do the same experimentation by omitting any other 100-digit figures. Okay, so that is how I have omitted 4 digits from the chart, and I have balanced my X values and my Y values together. Okay, so in the third sheet, I have noted down these X values, which actually that the prices of the fiction books, and these are the prices of the fiction books, and these are the prices of the non-fiction books. Okay, and now I'm going to study. Going to do the calculation on that. Now in statistical books, what happened? They give you this chart. They give you X data and they give you Y data, but you don't know what actually the X mean and what actually the Y means. You have the data only and you do the manual calculations. But I have shown you the behind the screen approach to reach up to this particular point. Now this is the time at which I can start my analysis. Number of data present in capital X and number of data present in capital Y are same. So first of all, I'm going to draw the scatter diagram. I'm going to select the entire chart. First of all, I hope you can see it. And then I'm going to click on this insert option. In insert option, you see this particular figure is there in insert option. Can you see the figure? This figure is there. It is called scatter. So I am clicking on it and several figures are being shown. From this figure, I am going to select this one. Okay. Now you see. Just a minute. Can you see how the data are scattered around? This is capital, this is called capital X axis, and that is called capital Y axis. And with respect to each of these points, I am actually showing you the behavior of the capital Y with respect to capital X. You can okay, so you have got your scatter points. Now in this scatter points is this scattered point is very haphazard. You cannot actually say whether these are actually linear or not. Okay, so this is not a proper straight line, and from if you consider the practical data, in practical data these things happen. The things are not actually always systematic. They has to be always scattered. There has to be some sort of chaos in it. Okay, now okay, somebody I think somebody has left. Just a minute. Somebody has left the meeting because of the network trouble. Okay, I have unlocked. Participants can join. Okay. Now you see this, after drawing the scatter diagram, at least I can say that yeah, okay, you can start, at least you can say that yeah, when the prices of the fiction books are increasing, the prices of the non-fiction books are also increasing, or it remains the same. You see, so the nature, I am moving my cursor, it is in increasing direction. This is the increasing direction of the price of fiction books, and this is the increasing direction of the price of non-fiction books. Okay, so I am doing it in this way, in this manner. So you can at least say that okay, these two things are positively connected. But what is the connection that you do not know? What is the connection you do not know? Now, but if you ask me that if we keep these prices, these high prices, if we keep these high prices in the picture, suppose a particular student asks me that, sir, that why can't we omit, if we omit the figures 445, 429, 449, 319, the last four figures from the chart, then why can't we do so? It is because the figures you are mentioning as the last figures, these are last figures because why these are last figures? Because you have made them last. You have actually noted these in the last part of the column. I could have written in the first part, then you, according to your choice, they wouldn't have been omitted. So that is not a logic. By this logic, you cannot omit these figures. And there is one another logic. Suppose I have suddenly decided that, okay, I'm going to keep these high prices, and by keeping the high prices, I'm going to take the first n items, first 9 items, and I'm going to do the calculation on the basis of these first 9 items. I'm going to do the scatter diagram on the first 9 items. Then what will happen? Let us see. Okay, if I draw the curve, let us see what will happen then. So I'm going to, let me select the prices. Just a minute. Let me select the prices. The prices have been selected, and I'm going to select the scatter diagram. And now see what has happened. See, look at the picture very carefully. This is your picture. Okay, let me format the picture a little bit so that you can understand properly. See what is happening. All these prices, if you look at these prices, you see these prices are approximately connected. They are near to one another, approximately. This is a little bit higher than this one, but they are near to each other. This is a little bit, these three prices are very much interconnected to one another. Almost they look like same, but all these prices are very near to the x-axis. Okay, so we do not have any problem with these prices, because why is it so? Because these are all 100-digit data. But if you look at these two prices, say this dot and that dot, you see what is happening here. This dot is actually corresponding to the point 7150, which is the very highest price for the non-fiction book, and this corresponds to 5429. It corresponds to the price of another book. Okay, these two prices are very much high. It's too high, and it is far away from the x-axis. These two prices are far away from the x-axis. Actually, these are 1000-digit figures, and these are not interconnected with. These are not interconnected. You cannot relate these two digits with the other 100-digit figures. Such a digit is called outliers. Their names are outliers. You can note it down. OUTLIERS, outliers. Okay. Why are these? When we actually plot the figures, when we do the scatter diagram also helps you to identify the outliers. And outliers are actually always problematic, and you have to get rid of them before you start solving the calculations. You start solving the problem. You have to get rid of the outliers. Okay, so these outliers, because 5429 and 7150 were outliers, I actually omitted them. Okay. Now suppose someone of you is saying that, sir, okay, you just keep this 95 in the picture and omit 449, any 3-digit, any, say for example, one person is saying that if we keep the 10-digit item, 10-digit figure, one 10-digit figure is kept, what will happen to the diagram? Okay, so let us omit this 449, this particular figure, and let us include 95 over here. Okay, suppose I am doing in this manner. So what will happen to the scatter diagram? Let us see how the scatter diagram will look like. So we'll put in, click on insert, and we'll go to the scatter diagram. We'll select this particular curve, and you see what is happening. Let me change the color so that you can easily see it. See, if we keep 95 in the picture with other 100-digit figures, then it is actually getting lost in the diagram of dots. You cannot easily identify it. Where is the 95? This is the kind of thing is happening over here. Okay, why is it so? This is actually 95. This is the thing which actually represents 95. But this 95 is actually not very much scattered it is not too scattered with respect to other figures. Okay, because this 95 is if we add 5 to 95, then a 100-digit figure will come out. So 95 is very near to the 100-digit item. So you cannot say that 95 is the outlier. Just because it is a 10-digit figure, you cannot say that it is an outlier. Okay, so outlier is a kind of thing which is shown in this particular picture. I'm again showing you what is outlier. You will get to know it properly. So that is called the outlier. This is called the outlier. Okay, suppose you are sitting in a pub with your friends. Okay, 5 of your friends, and you are discussing about your yearly expenditure, what your investments are, and how you are going to save your investments for the future. Okay, what are your retirement policies, etc., etc. 5 of your friends are discussing, sitting in a pub, and suddenly a movie star joins you in. Okay, and he also starts discussing. It's a very ideal situation, but you can imagine anything. He suddenly joins in and he starts discussing about his investments and his expenditures and what is his retirement policy, etc., etc. And if you collect all the information from the discussion, and if you plot it in a diagram, if you plot the scatter diagram kind of things, you will see that this movie, the movie stars investments, retirement policies, expenditures, incomes, everything is too high with respect to yours. So that movie star is outlier. You shouldn't allow him to move into your discussion. This is an outlier in your group. So before you study your investments, before you plan your investments, you have to get rid of outliers. And therefore, this scatter diagram is very important. Okay. Now you see, when you will do project works in BBA, and the teacher will tell you that, okay, you have to find correlation coefficient between the two things. What students actually do, they get the data and start solving the calculation without studying the nature of the scatter diagram. But before you start calculating the correlation coefficient, you have to know first of all the nature by you drawing the diagram of dots, and if the nature is suitable enough, then only you can go for the calculation, otherwise not. Okay, many people do these kinds of mistakes. I am actually recording my today's session, as you can see, and if possible, I am going to upload this video of this particular class in my YouTube channel. Since some participants are not present in today's class because of some reason or other, I want them, whenever they get the access of the internet, I want them to go through the video. So you tell your friends that sir has taken the class and he has uploaded the video in the YouTube. I will send the YouTube link in Google Classroom so that each one of you can see my videos once again to understand this particular part. I am spending too much time in discussing scatter diagram because it is important and it is often neglected. Scatter diagram is often neglected. Teacher comes to the classroom, he says that scatter diagram is capital X is increasing, capital Y is increasing, positively correlated, capital X is increasing, capital Y is decreasing. Okay, then it is negatively correlated, and you can put the diagram of dots and you will see that this is called scatter diagram. That's it. The end of discussion. Students are happy, teacher is also happy, but the basic utilization of scatter diagram has not been discussed. So with a proper example, with an example from my personal experience, I have tried to make you understand what scatter diagram is and what is its utilization. So before you study correlation, you have to understand what is the nature of the scatter diagram. Now you can ask me that, sir, too much about scatter diagrams, say something extra. Okay, it is too you have discussed so many things about scatter diagrams, so what next? Okay, we have understood this, what is scatter diagram, and we can actually draw the scatter diagram by ourselves. So what we can do right now, okay? So let me change my figure. Let me change my figure. See, when I changed the figure, it was 95. Look at this particular dot. If I change the figure from 95 to 449, the position of the dot will change. See it. See what is happening. 449. See, the dot is moving upward. Now I have adjusted my particular chart in this manner. Correlation coefficient, calculation of correlation coefficient, the formula which I showed you, the formula probably you have written, which is in front of you. I'm going to find the correlation coefficient using the Microsoft Excel. Okay, so it is a matter of a click. What will I do? I will first of all select a blank cell here, and I will double click on it. I will put a blank cell here and I will double click on it. I will put equality sign. Okay, and I will go to the section. I will write core. Yeah, what is written? Core RREL. This is the code. Core RREL. Corel. Corel stands for correlation. And you see, this is coming. After clicking on it, this is coming. Two arrays are there. One is called array 1, another is called array 2. Array 1 stands for capital X, so we can select the values. Array 1 has been selected. Put a comma. Now you select the array 2. Array 2 has been selected. Okay. Array 1 is in blue color, array 2 is in green color. Close the bracket. Enter. And that is your correlation coefficient. 0.635832. Correlation coefficient between the two variables capital X comma Y is therefore found out to be 0.65 approximately. I can solve the calculation manually. I'm not actually showing you the manual calculation because I have actually decided to show you the real essence of the software and the practical statistics. I can do the board work anytime later. So correlation coefficient, what is the nature of the correlation coefficient? You see, you can relate this particular value with the figure. In the figure, although these are haphazard, the diagram, these dots, the dots are scattered, but you can at least say that the dots are in increasing direction. Capital X is increasing, dots are also increasing. And what did I say? I said if the two variables are in the same direction, capital X and capital Y, both of them are increasing or both of them are decreasing, then there is a positive correlation between them. So you see, the value 0.65 is actually positive. The value 0.65 is actually positive. And from this also I can say that capital X and capital Y are positively connected. What is the conclusion? Try to understand. Your teacher has asked you, your supervisor has asked you that, okay, you have found the correlation coefficient between the two variables. What is the conclusion from? What conclusion can be drawn from your calculation? Because you know capital X and capital Y are the prices of the fiction and non-fiction books. Okay, so since they are positively correlated, I can draw the conclusion. You can draw the conclusion in the following manner. You can say that, yeah, we can at least say that since the algorithm of the Amazon is designed in such a way, the algorithm of Amazon is designed in such a way that if the algorithm is increasing the price of fiction books, it is also increasing the price of non-fiction books. Very beautiful analysis, you know. You can do the experiment by yourself with your desired product. Okay, the girls want to buy ornaments. Say they can study their buying history of the ornaments, various types of ornaments. Boys are too much fond of gaming videos. probably you have bought gaming videos from Amazon. So you can set two variables, you can define two variables, different types of gaming videos, violent gaming video, non-violent gaming video, and their price list, and you can try to find the correlation between the two. But from my addiction with respect to the books, what I can say that the correlation coefficient actually tells me with respect to my sample, small sample, that why is it small sample? Because sample size is just 13. 13 is not a very large number. Okay, so I can consider this to be a small sample. So with respect to my sample, my manipulation, I can at least say that the algorithm of the Android of Amazon, when it is increasing the price of fiction book, it is also increasing the price of non-fiction books. But you can say that, can you universalize your conclusion? This answer is no. Because to universalize this particular thing, to generalize my statement, I have to have many more data, not only 13, maybe 1300 data I have to work on. And then I can say that, yeah, okay, to some extent, this thing is happening. Okay, so that is how the correlation coefficient is studied. You can ask me that, sir, why aren't you showing us the calculation of correlation coefficient using board work? Okay, someone says, Depottam says that Dipanjan Ganguly is facing network issues. No issue. Dipanjan, tell Dipanjan that no issue. I'm going to upload the video in the YouTube. And students, I'm actually uploading the video in the YouTube because today I can see that there are 36 participants. For your kind information. But if in any particular class I see that this particular number of participants is less than 30, okay, for your kind information, when the size of the sample is more than 30, it is called a large sample. And when the size of the sample is less than 30, it is called small sample. Okay, that is the formula. When the sample size is larger than 30, it is called large sample. And when the sample size is less than 30, it is called small sample. So if any class I see that I am teaching small sample, then I shall not upload the YouTube video. And if in any class I find large sample, then only I will upload the video. So don't think that sir is going to upload the video always, and you always, by being absent, you always will get to know about what is happened in the class. If only I have the large sample, then only I am going to upload the video. That is the condition, predefined condition. So okay, so for what was I saying? That you can probably tell me that, sir, why aren't you showing us the manual calculation in the board work? So if I am going to show you the manual. Okay, I'm telling you, don't worry. The countdown of the session has started. So after the session ends, you rejoin for 10 minutes and then only you can place your questions. I'm going to answer all of your questions in that session. Let me finish, let me wrap up my today's class. But after this, you rejoin, okay? So what was I saying? That I am not actually showing you the manual calculation on the board, because one or two classes have been taken with respect to module 1 and module 2. You do not know what measurement of central tendency is. So measurement of dispersion is. Okay, so probably your teacher will tell, the other teacher will tell you. And I am hopeful that in this particular week, probably she will at least cover the measure of central tendency part. That means the arithmetic mean. If you get to know what arithmetic mean is, then my purpose will be solved. So since students are not always comfortable with manual calculations, okay, and nowadays the patience level of the students have decreased, okay, so I actually wanted to have you some kind of feel for practical examples. And if you want me to do the manual calculation on the board, and yes, I definitely have to do the manual calculation on the board because it is expected, then I must say, then you go through any statistics book and you go revise your knowledge about arithmetic mean, if you had, and standard deviation. Try to get hold of that formula, mean and standard deviation, and then only I can easily, I will become, I can remain comfortable in discussing the things with you. Okay, so my prerequisite for manual calculation of correlation coefficient is about this arithmetic mean, that will be required as a tool, and standard deviation will be required as a tool. So you can note it down, and before coming into my next lecture, you can revise the thing from, you can get to know the things from the book if you already knew it, and if you do not know the, if you have not heard about these names, then you can watch any YouTube video on arithmetic mean and standard deviation. Many YouTube videos are available, and they are also easily accessible, and you can get to know what is happening over there. Okay, so actually this particular syllabus cannot be divided into two parts. Actually, one particular teacher is supposed to take the class, but because of some constraints, we actually share things. Okay, so that is the problem with this particular subject material, where everything is interconnected to one another. So I'm actually going to give you a task. You have come to know how to use Microsoft Excel to calculate the correlation coefficient and to draw the scatter diagram. Your task is to, your homework is, you don't have to submit the homework. It is just a, take it as a fun. Your homework is, you select two variables of your choice. Okay, and try to find the nature from your practical experience. Okay, not bookish, something very practical. You're buying history, or your you can anything. Examples are not coming to my mind. Your examples are your examples. You can only think of that. So you choose two variables from your practical experience, and with the help of Microsoft Excel, try to find the correlation coefficient between them. Try to draw the nature diagram. If outliers are available, try to omit the outliers. Take a huge amount of data. It is expected that if you deal with 50 data or 100 data, things will be much more I mean to say convenient or significant. You can take variables of, you can consider the variable investments of your parents as variables. Your mother has invested, your father has invested, so consider their investments together. You can find the correlation between the two. So you can play with this particular thing and the Microsoft Excel and throughout this week. Okay, before you come to my next, because before you join my next class. So this is the thing which I wanted to discuss with you in today's session. In the next session, I'm going to tell you what is happening behind the screen, because this Excel is built upon an algorithm. Some algorithm is playing behind it. If I talk about the correlation coefficient 0.65, some algorithm is behind that. What is that algorithm? What is that formula? I am going to talk on that in the next class by doing manual board work. Okay, so here I'm going to end my today's session officially. Countdown has also started. So after the class ends, if you have any question, you can rejoin and ask me question. I'm rejoining and I shall be there for 5 minutes. Okay.